What are the alternatives to traditional math programs? These are the kind of questions we are asking as we jump into homeschooling. And what happens is oftentimes we will pull our kids out of school. And because, that's how we were schooled by sit in your desk, do the book. And that's how we were trained. And therefore, that's what we do. So we see a lot of people pull their kids out of school and they do school at home in the same setting. That works for many, that doesn't work for all. But what we always talk about all the other methodologies, and yet I don't find a lot of different people doing different things. We even in the programs that are being sold. So, but let's just talk about what traditional means, because you might be looking for a mix up of the traditional. So let me just say offset is what usually is successful is a mix of what's traditional and what's doing some other creative things. And you have to figure out a fit for not only yourself, but for every student. So none of these are bad, none of these are great. It's just what fits for you. First, what do I mean by traditional? When you say traditional, people think big fat textbook, a lot of busy work. The teaching method oftentimes feels disconnected with real life. Now, that's fuzzy what I mean by there, but math or any other subject should connect to reality at some point, because we don't want to just putting numbers on the wall just to put numbers on the wall. There's a point to it. We should be solving real problems. So that disconnect, though, is true in a lot of what we consider traditional programs. It's the same stuff in schools. We just brought it home. And like it or not, that's what happens in a lot of the school systems. And it's not because the teachers are not necessarily capable, but the system they're in has restrictions. And of course, they're dealing with 30 plus students at a time that force them to have to just focus on the basics usually. So this approach does work. So in case you want to dump off on it immediately, this approach works with some students. Uh, for some, it just doesn't click. Many find it are overwhelmed by the pace, or they are just bored. They just want something a little different. Because there's a little bit of repetition. Hey, do this, work the problems, do that. And we never really see the connection to the real world. Now, when we see these students come that have been nothing but traditional programs, they come into things like academia at the higher ed level, and I can speak to engineering. A lot of times they have done, for instance, a lot of math or a lot of science, but they don't really understand what they did. It's what we call cookbook learning. We can follow the recipe and we can do it, but we don't understand. We are no chef. We cannot take ingredients and figure out what to make with them. So that's the difference between a chef and a cookbook follower. Or that's one of the approaches. That's kind of the most common approach that we see, and that's what we traditionally think of as a traditional program. So the alternatives, just a couple of alternatives here is, and by the way, there's probably an endless supply of alternatives. So I'm going to give you little pockets of things, but combining them, you get some really creative things. So, first is concept-based programs. These would help you understand how they work. In other words, instead of teaching you, just the numbers and the algebra or things like that, we're going to look at the concepts, how these things work together. And this goes exactly to what I was just talking about, a cookbook. We're not teaching you how to follow the recipe. We're teaching you how to create the recipe. We're teaching you, and when we're talking about math, we're teaching you about the relationships, because anytime you said X equals something something, it doesn't matter. That equal sign is a relationship. And how do these things relate? And understanding what's going on and what do these numbers and symbols and charts, what do they represent in the real world? Because that's how we use math. We use it in the real world for things, everything from shopping to the most advanced space shot. So so that's what a concept-based learning program is. Harold Jacobs programs that we use for algebra and geometry are concept based. Uh, because we want people, and that's the reason we did not write these books. Obviously, Harold Jacobs wrote these books, but we chose them because he did a great job of teaching the concepts. And so many programs are what we would call cookbook learning. They teach you how, when you see a problem that looks like this, use this formula, but they don't tell you why, what's going on, what does that formula mean? So that's what we're looking at here is concept-based programs. And if you're teaching anything, that should be fundamental. So you may have a traditional program and you need to mix some concept things in to help them understand. Uh, that would be fine. But getting them to understand the concept, especially on a course they're going to use, most people who are taking our programs are probably going into higher ed, mathematics or engineering or something like that. So they need to understand the concepts. The second thing that kind of is an alternative, and by the way, concept-based programs you can learn out of the book just yourself if you want to, or workbooks, or however they come. There's great many options, and especially if we go to the university level type material, there's just most of them are laid out that way. Uh, the second thing is that you have as an alternative to you sitting down teaching at home, which makes mom the teacher, is, of course, video-based instruction. Many people are comfortable teaching lower grades, but when high school comes, this is one of the things we find is how do I teach it myself? And one of the things that you want to do is probably you want to do is move away from being just the teacher to the teacher and coach, the guider, the leader. And so that means you don't have to be an expert. So the video-based programs can supplement you, and we do have a lot of people who we have a lot of people who buy our programs who are engineers or mathematicians. They know this stuff. That's not their issue. It's an issue of time management, and it's also, let's face it, it's an issue of Johnny and Susie might not learn as well from mom and dad as they will from another person. And so that this helps reinforce what they're teaching. And so the videos can teach a concept, they can teach the how to do things, they can show examples, and then mom and dad can supplement that or support that. Uh, or some people who just turn Johnny and Susie loose in front of the videos and give them the book and they handle it all alone. So you have multiple variations of how you do math. And this is the beauty. This is why we homeschool again, right? Is because you have control. Somebody's not telling you how to do this. Nobody is telling you how to educate your children. You have a lot of flexibility of how you do it. And you want to do it the way that is the easiest for them to learn and what the less painful for all people involved, including you and the student. So this is, but the video-based things, if they're an independent learner, it's a great way because they still get the teacher. In our case, at least you get support. You get it, so you just get a great mixture there. And of course, people who want that are quasi-independent or they're growing their kids to be independent, it's a great model for that because they can kind of transition to that. Uh, so that's the concept base and the video base, and then the another one here is what we would call project-based learning. This is great for hands-on learners, and it is probably really going to be best at the higher levels. Now, when you go into the lower levels, you might see manipulatives and things like that, like Matthew C. Is famous for doing. That's great for teaching some basic addition, subtraction, all those basic fundamental rules. That doesn't translate perfectly into the high school years, although some people do it that way. But projects, or these are programs connecting math to the real world situations, like budgeting, like shopping, like we see these engineering teams, we see architectural teams, we see robotic teams, or where we actually going to try to apply the math to something real and having the students use their hands or use their computer or doing something that's more on the physical elements and using the math to do that. And they're kind of learning the math to do this. Um, we see this as a very, very popular approach at the university level. So there's been a lot of research, and maybe it's our current culture that this is what we're doing a lot at the university level is project-based, team-based activities. I mean, does it work? It has its pros and cons at the university level, but it can be a fantastic tool to, if nothing else, supplement all the other things that you can take a project and say, hey, let's apply this. And it could be as simple as when they're doing geometry is, let's measure the square footage of our home. And so they keep measuring different rooms and different rooms with different shapes and how rooms fit together in hallways. Because if you think of the house as not one big square or rectangle, the house has rooms and they're offset by hallways and bathrooms and everything. So this is a perfect example of all the area, the sum of all the areas equal the sum of the parts. I didn't say that right, but you get the idea. We're but it's a geometric hypothesis. So what we're trying to do is teach this by physically holding something and doing something. So it's that kind of project. And in Harold Jacobs' geometry, you have all these kind of things. He does many of these projects. He talks about these projects and a lot of things, even though they're problems and they're written down, that's what they are. And so the student can take and go do themselves, or they can just say, "Hey, this represents a house, and I'm doing it." So it's kind of project-based learning embedded in a textbook. So the fourth thing that we see is a slower based program, which this isn't really necessarily a different type, but I feel I should bring up this as an alternative because there is a lot of pressure, right? As homeschooling parents, you still feel pressure, right? Even though you are not in school and there's no principal or no school board telling you where you have to be. And even if your cover school gives you a lot of leeway, there's still pressure from friends and peers and things like that. It doesn't matter because where most of my sight of this comes from is on the end game. We look at people that as they come into college, and we see people come into college from very high-end public private schools, from some very average or low performing public private schools, which there's plenty of those, and from homeschools, we see it from kind of every walk of life, even coming from other nations. And they will oftentimes start at different places because they got to different places. They understood they're not all walking in the door equal, but they can all end up in basically the same place. Now, is it great if they come in with a true solid understanding of calculus and all of that? Yes, that's awesome. But we also see a lot that come in who have taken calculus who really don't understand algebra. They kind of forced it through in a cookbook method. They're not better off. They're not better off. Actually, the person who's, is behind in math turns out to be better off because they probably understand what they're doing. So I say all that to say the slower based options is one of the great alternatives, which is where you are in control as a teacher. You can say, this book, here has 16 chapters, the course, the video, whatever you're using, and it doesn't want to matter what book it is I need, and we talk to parents all the time that feel incredible pressure to be exactly with our syllabus that we've written. And we tell them our syllabus is a guide. It tells you about where you should be every week if you want to finish in so many weeks or so many months. But you are the leader of the classroom. You are the leader of the education. And so if you say, you know what, I'm going to divide all this by two, and what's for week one and is going to be for week one and two, and what's for week two is going to be week three and four. That's fine. Because And it doesn't matter. I mean, you feel pressure for doing this, but what matters is that they're moving forward. Now, if you're not doing anything all day, okay, that's another issue. But if we're just moving forward and we're moving steady and we're moving faster, which also happens, or slower, we get emails from parents who feel like they're not moving fast enough, and we get emails from parents who feel like they're moving too fast. And what if Johnny is done too fast? What do I do then? Both of those are easy problems to solve. You are in control. The main thing is what they are doing. Do they understand it? Speed is irrelevant. So you get to be in control. So I call this a slower based alternative, but for you, it may be they're going faster. We also, oddly enough, have a lot of people who will do algebra and geometry at the same time, or they'll get through algebra for a couple of chapters and they will also pick up and say, hey, I want to do geometry at the same time. That actually can work really well for many students, but that's the flexibility that you have, right? So I'm giving you a couple of alternatives here. Concept based, being focused on the concept. And by the way, I would suggest that whatever you do should have that in there. Video based can be a great tool for you. Project based and changing the pace to what you are doing. So the last thing I want to leave you with here is that you are not behind. You are teaching a person, not a system, not a box, not a robot. So you're not behind. We are all just learning at different paths. Um, some of us excel really, some of us are I was going to use the word exponential, but let's not go too mathematical here. Some of us begin very quickly and learn very fast, but oftentimes we'll tap out. We'll get to a point where that's kind of our speed of learning slows down. Others are very slow to get moving. It doesn't matter. You are not behind. The goal is not just to finish the book by the deadline or the arbitrary date that's put on there for the average student, and the average family with 2.4 children, it's to get them to learn the material, to help them understand it, to help them embrace it, and be able to move on. So, if you're exploring opportunities or alternatives to math, check out what we've got. We've got some links here to some of our math courses. Many people come into us from other programs, and we'll start in Harold Jacobs Algebra. Some people will go all the way to calculus. Some will just get through algebra and geometry. And again, that's the beauty of you being in charge of your own education.